Welcome to FREDA. The FREDA web application provides a processing, visualization, and analysis pipeline for FTICR data. This video will walk through the available functionality of the web tool. FREDA is grouped into tabs, each representing a distinct step in the workflow. When first visiting the website, you'll land on the Welcome page. Underneath this menu tab, several other pieces of information are available. In particular, the Data Requirements section will help you get started in understanding the format your data must be in to use FREDA. FREDA requires two CSV files. The first file gives quantified data or peak intensity information. Each observed mass is a row in the file, and each sample makes up a column. The second required file is a molecular identification file. This file gives information about each observed mass and molecular information in the form of a formula or elemental counts. Example data is available by clicking the download button at the bottom of the page. Next, we'll take a closer look at each of these files. Here I have the two example files from FREDA. We'll first look at the data file, which is labeled example 12T eData. Here you can see that we have one column which corresponds to a unique mass identifier, and the remaining columns contain peak intensities for each sample that was run through the instrument. Next, the molecular identification file is labeled example 12T _ emeta. In this file you can see that we have that same unique mass identification column, and for each mass we have elemental counts for carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus. An alternative to the elemental count columns is for the user to provide one column which gives the molecular formula of each peak when available. Once we're ready to begin, we'll click on the Upload tab. Here we'll select the files that we wish to analyze. First, we'll upload the data file by clicking on the Browse button and selecting the data file that we described earlier. Once this file is uploaded, you can see a preview of the data on the right. Next, FREDA prompts us to select the column that contains the unique mass identification. Here we select the column titled Mass. Next, we'll upload the molecular identification file. Again, a preview of this data is shown down below. We can then finish our data upload process by answering the next three questions underneath our uploads. We first select which instrument generated this data. In this case, 12T is the correct option. Next, we select whether we have formulas or elemental columns. In this case, we have elemental count columns. FREDA will then attempt to infer the correct column name for each of the 6 elements. In this case, we can see that it's correctly chosen column names for each of the 6 elements. Finally, we're asked if isotopic peaks were identified. For this data, we do have a column which is labeled C13, and for masses where isotopic peaks were identified, this column takes a value of 1. From the drop-down menu in FREDA, we indicate that we do have isotopic peaks identified by selecting Yes. We're then asked a series of follow-up questions, whether we'd like to filter these isotopic peaks from the data. In this case, we'll select Yes. We then need to indicate which column contains this information. As I mentioned earlier, that column is C13, and we then enter the symbol that denotes whether an isotopic peak was observed. In this case, that is denoted by a 1. We've now filled out all of the relevant information to upload our data, so we can click Process Data. Assuming that we've filled out all of the information that FREDA needs, an upload success message will pop up. We can either choose to stay on this page and review the results, or click the button to continue to the next tab. In this case, we'll click on Review Results. FREDA has summarized how many peaks were observed in this data file, as well as the number of samples and peaks with formulas assigned. We can then move on to the next step by clicking on the Pre-Process tab. Here we have a variety of quantities and information that can be calculated about each peak. At a minimum, we recommend selecting the elemental ratios and the Kendrick mass and defect. And if you're unsure about what any of these quantities are, extra information can be obtained by hovering over the question marks or by looking up the term in the glossary section of FREDA. In this case, we'll calculate the default values as well as the nominal oxidation state of carbon, aromaticity, and finally general compound classes can be calculated using elemental ratios. In this case, we'll use boundary set 1, which assigns compound classes based on oxygen to carbon and hydrogen to carbon ratios. Here we can see that more information can be found in the Kim et al. 2003 manuscript. Once we've selected our quantities of interest, we can click the Process Data button. Again, we're prompted with the same menu as on the previous tab, where we can review the results and stay on this page or continue to the next step. If we click Review Results, FREDA gives us summary statistics for each of the values that we've calculated, and for categorical variables such as compound class, it shows us the counts for each category. Additionally, we can look at the distribution of any of these values across all samples. Here we see the distribution of oxygen to carbon ratio. We can also select any of the other variables that we've computed. In this case, if we select the compound class variable, we then get a graph of the observed distribution of the different classes. We can then move on to the Filter tab. When we first arrive at the Filter tab, on the right we get a plot of the current number of peaks in our data set, broken out by the status of formula assignment, as well as a tabular representation of these results. On the left we have a variety of filters that can be applied to the data. In general, the filter page allows the user to specify peaks or masses which should be retained in the dataset after filtering is done. FREDA has 3 common filters available, as well as a custom filter based on any variable present in the dataset. The first filter is a mass filter. This is commonly applied to FTICR data to specify the range of mass values for which data is trusted. In order to apply this filter, we click on the box next to the filter name. On the right, you can see that the graph is updated to show the effect of applying this filter to the data. The second available filter allows us to specify the minimum number of times a mass or peak should be observed in order to be retained in the dataset. In this case, we'll check that filter as well. The third filter indicates that masses or peaks for which a formula could be assigned are retained. We can see that if we check this filter, the graph now represents that there are no peaks for which a formula could not be assigned. We have the ability to implement a custom filter based on any of the other quantities in our dataset. Once we check that box, we can then select the next variable which we wish to implement a filter based on. We're then prompted to provide minimum and maximum values of the peaks to keep. In this case, we won't implement any custom filters. Once we're satisfied with our filter choices, we can click on the Filter Data button. In this case, we'll continue to the Visualization tab. The Visualization section of FREDA has many options available. We first begin by selecting the type of plot that we would like to make. We can see here that Van Crevelen plots, Kendrick plots, density plots, and custom scatter plots are available. Here we'll start with a Van Crevelen plot. We're then prompted to select the unit that we would like to plot. Here we can choose to plot a single sample's data, multiple samples that belong to the same group, or we can plot a comparison of groups. Here let's start with a single sample. We're then prompted to select which sample we would like to create a plot for. Once I've selected my sample, I can then click on the Generate Plot button, and my Van Crevelen plot appears. Here we can see that the data points are being colored by an error value, which was present in the data that we uploaded. In order to change the variable that we're coloring points by, we can simply go to the Color By menu and select the variable that we're interested in. Here we'll color our points based on the compound class. Note that we can explore our plot further by hovering over points, selecting different classes of points to turn off and on, or zooming in. We can also customize labels for the axes or the plot title. In this case, I'll name my plot after the sample that I've selected. Once I've made my changes, I can click on the Update Labels section for that to be reflected on the graph. If I'd like to save this graph, there are two options available to me. One way this can be accomplished is by moving my cursor over the plot and clicking on the camera icon. This will download this plot as a PNG to my computer. Alternatively, if I'm going to create several plots, or I'd like my plot to be saved in a format other than PNG, I can scroll down and click on the Store These Plot Parameters button. We can then see that information about this plot has been saved in the table below. This indicates that the plot will be available for download on the next tab in FREDA. Next, we'll generate a Van Crevelen plot for several samples that belong to a single group. We can change the plotting unit under the second drop-down menu by selecting multiple samples by group. You can then see that we're now prompted to select the samples that belong to this group of interest. If we click on this box, a list of samples will be provided, and we can simply click on all the sample names that belong to the group we wish to plot. We then click on Generate Plot. By default, each point in the Van Crevelen plot is colored by the number of samples in which that peak was observed. Alternatively, we can select the proportion of samples that peak was observed in, or any of the other previous options. Here I'll update my plot title, and save this plot for later download. We can now see that the table indicates I'll have two plots available for download later. Finally, we'll create a Van Crevelen plot comparing two groups. Again, if we go under the second drop-down menu, we now want to select a comparison of groups. We're then prompted to specify the samples that belong to each of the two groups. Next, we must specify how we want to determine whether a peak is present. Next, we need to specify how FREDA should determine if a peak was observed in a group. We can either do this based on the number of samples for which a peak is observed, or the proportion of samples for which the peak was observed. In this case, we'll select proportion of samples. We then need to specify the metric which determines whether or not a peak was observed uniquely in one of the two groups. One option is to determine uniqueness based on a G-test. This is a qualitative test that examines the patterns of presence and absence to determine if they're related to the groups that we have defined. Alternatively, we can select presence-absence thresholds, which allows us to use the same metric that we've selected above. We'll use that metric here. Finally, we need to determine the thresholds for presence and absence. Here the default values are 1 and 0, indicating that for a peak or mass to be determined to be present for a group, it has to be observed in all samples, as indicated by the proportion of 1. Alternatively, the 0 and the absence threshold, in order for a peak to be denoted as absent from a group, That peak must be observed in none of the samples. In this example, we'll proceed by requiring a peak to be observed in 75% or more of our samples to be considered present in a group. Additionally, we'll define a peak as absent from a group if it's observed in 25% or less of samples. Once we've made our selections, we can scroll down and click the Generate Plot button. The resulting Van Crevelen plot shows us the points that were uniquely observed in Group 1 in red, uniquely observed in Group 2 in blue, and peaks that are observed in both groups. To get a better view for which peaks were unique to each of the groups, we can click off the Observed in Both and investigate further from there. There are several other types of plots available in FREDA. For example, the Kendrick plot, which is a common figure made in FTICR data. The density plot. Here let's make a plot using a single sample. Again, clicking on the Generate Plot button. We then see the observed distribution of the selected variable for this particular sample. In this case, we've defaulted to the error value. However, we can select any other variable of interest. For example, NOSC. Once we've finished making our desired plots, we can move on to the download page. On this tab, there are 3 distinct file types available for download. First, we can download the process data. This is the data after calculations and after filters were implemented. The first file type is the process data. This is the data including the calculations made on the pre-processing tab and after filters were implemented on the filter tab. We can choose to download this data in 2 separate files, similar to the format the data was uploaded in. We also have the option of downloading the data as a single file with all information combined. In addition to this, if we've made any plots where we've indicated groups, we can download the data that corresponds to these plots. For plots with a single group, this will consist of observed peaks, as well as the number of samples and proportion of samples for which each peak was observed. For plots comparing 2 groups, this will consist of the observed peaks and whether or not they're unique to each group or common between the 2 groups. Here we'll choose to download the data in the same format as which we uploaded it. In addition to the process data, we automatically get a summary report of the steps that were taken in pre-processing and filtering the data, along with citations and documentation of the quantities that were computed. Finally, we can select the figures that we would like to download by clicking on each row of the table that corresponds to the plots that we would like to download. In this case, we'll download both. And finally, we select the format we would like these images to be downloaded in. Once we've finished with our selections, we click on the Download button, and these items will download to our computer in a zipped file.